For example, this is my voice signal, which is analog. By doing our pulse coded modulation and quantization, blah blah blah, quantization, we convert our analog signal to a complete digital code. This is actually our digital code, pure digital signal. Now, if do you want to transmit this digital signal directly, or you want to do engineering? Mind that if someone can track this one, he will get whole of information, right? Like if someone, when you are transmitting signal, someone trying to hack your information, right? They will get the whole information. There is no secrecy. What you want to do, you think, okay, I will not transmit one directly. I will encode my one is 010. I will encode my 0 is 001 or whatever, something like that. Okay, means now this is a secret code, becomes a secret code. Okay, so what do you think? This is the code length, eh? So you see here code length is 3. The higher the code length is better, or lower the code length is better for this encoding?
Higher.
Okay, you should ask me question that actually based on what? That should be the question. When I ask you, what do you think? If higher is better or lower is better, your question should be, okay, in terms of what? Many things could be. So in terms of security, if you increase 0010100, you see lots of code is used just to encode this one. Means actually it will be hard to hard for someone to trace it, like hack it. Even they hack it, they cannot retrieve the data. But you see, you had a 1 bit. You, instead of 3 bit, you convert it to how many? 1, 2, 3, 4, 5, 6, 7. Means actually you increase your what? You increase the symbol, right? Whole symbol. But when you are going to transmit, this is, for example, this is your transmission bandwidth is 1 kilohertz. When you transmit this signal, whole signal, by using this way, you can use the whole 1 kilohertz, isn't it? But when you will use this code, what will happen? This code will divide by 3. You can use 0.3 kilohertz, isn't it? Because you see 001 will be accommodated. It's still it's a single bit. Even if you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for example, if this is the case, then it is 1/10 of the information can be transmitted, isn't it? Because your bandwidth is the same, but you increase the code word, what will happen? You will decrease the transmission speed, data rate, isn't it? So by increasing the security, you lose something. So there is a trade-off. Whether what you are looking for, you are looking for very high, like secured stuff, or very high speed. So probably there is a trade-off, isn't it? Means you need a optimum bit length, or sorry, code word. This is a code word, optimum code. So you need, it cannot be 3, it cannot be even 10, in between something. We do not know. So in our first lecture, we have 2 lecture. From source code, we have 2 lecture. In first lecture, we actually give you idea of prefix free code. Prefix free code. What does it mean? Prefix free code. Huh? You know prefix, right? How something is came in front of something, isn't it? So in prefix free code, okay, let me give you an example. How for example, you have symbols S0, S1, S2, S3. Imagine S0 will be, we have 4. We have, so S0 will be 0. S0 can be anything. S0 can be like 00, 01, 10, 11, or anything else, or any of this combination. We are not confirm of this one. We are just saying S0 as a symbol, any of the symbol. S1 will be converted as 1 or decoded as 1. S2 will be decoded as 00. Sorry, encoded will be 00 or decoded, whatever, and 11. Okay. So you see here, these are the two length code word. This is 3 length. The length of this code is 2, and the length of this code is 3. Okay. Now you see, if I change now, if I whenever you are transmitting this one, this is a new transmitter. In the receiver, for example, you receive 0, 0, 0. Now what you receive? It can be this 0 is S0, S0, and this 0, 0 is S2, isn't it? Or it can be 0, 0 means S0, 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 or it can be S2 and this is S0. See, lots of way this signal can be decoded, isn't it? Because you decoder do not know it. Why this confusion happens in your decoder? The reason is that you see this guy S0 is in the prefix of this code, or 1 is in the prefix of this code. That's why your signal got confused. Means this system is not a prefix free code. Is not a prefix free code. That's the reason this happens. So what we want? We want prefix free code. Right? We always want a prefix free code. Now, in the second lecture, in the lecture 2, we discuss about the binary tree. Binary tree. This is actually a visual representation of this prefix code. There, we actually can see visually that if a code word is really prefix free or not. Let me give you an example. Let me give you an example. Okay. So S0, I write in again, S0, S1, S2, S3. 1 0, 0 0, 1 1, 1 1 0. Now the equivalent of binarity of this signal is, so this will be your root. From root there will be 2 branch. One branch, upper branch will be always 1, lower branch is always 0. Okay. So 1 0 1 1 0 will be what? 1 0 is S0. So this code is S0. 1 1 1 1 1 will be what? You see 1 1 1 1 is S2. This is an S2. So 1 1 0 is 1 1 0, which is S3. And 0 0. So 0 0 0 0 is S1. You see here, if I want to go to S3 from this branch, from this root, what will I have to pass through S2, then I have to go to S3. Means S2 is the ancestor of S3. Means actually S2 code will automatically will be in S3. S2 code is automatically in the S3. Means they are not prefix free code. They are S3 has a ancestor. This is not a prefix free code. Okay, let's take another example. Okay, so another example. Again, S0, 1, 2, 3. It's 1, 0, 1, 0, 0, 1, and 0, 0, 0. So what is the equivalent binary code for this guy? So this is the root. Upper branch is always 1, lower branch is always 0. Upper branch is always 1, lower branch is 0. So this will be S0. This one S0. So 0 1, 0 1 is S1. S1. So 0 0 1 will be S2. S2. And 0 0 0 0 0 0 will be S3. You see here no code is ancestor to any another one. They're independent. This is we call prefix free code. Prefix. And this prefix free code is very much visualized by this tree diagram, because these codes or these symbols are in the what? are in the leaf of this tree. If they are in the leaf of this tree, means actually this is a prefix free code. Okay, means actually if you represent your code word by this way, your decoder will never be confused. Your decoder knows which is what. Okay, now we will actually see a this is about the our last two lecture. In the lecture we concluded this L is greater than equal to hx. We concluded with these remarks. This was a conclusion. What is this L? L is the average code length. Okay. What is this hx? Hx is nothing but the entropy of your system. Okay. Now what this system is trying to tell you, what it is actually trying to say. We actually concluded in our last lecture that L is greater than or equal to Hs, means actually entropy is a lower bound for the average code length. So means your average code length has to be or at least equal or greater than the entropy of this. So this is the fundamental limit on this average code word. So entropy is the fundamental. Your entropy cannot be less than or otherwise the length you choose, the code word means how many code you choose to convert it. For example, this one, you see, you use this one 0 or it's 10. What should be the code word? That's actually limited by this entropy. That's actually the fundamental limit. The question is, what is entropy, guys? What is entropy? Anyone knows? You you did this course, numerical analysis. Numerical analysis. Probably this was your mandatory course in your second year, right? There you know the entropy. So what is the entropy? In general, not for information system. In information system, what is entropy? Entropy is defined as the average uncertainty associated with the source. This actually average uncertainty associated with source or source signal, whatever. In our cases, our converted, this is actually our source signal. Our pure digital signal was our PCM signal was our source signal. So what is actually in physics, entropy actually is related, probably we know it from some gaseous box, right? How entropy in a closed contained box increases by time, because by time the compressed gas expands. For our case, what is that? Average uncertainty. There is an uncertainty always associated with the source. You see, just for understanding, uncertainty is good or bad for general event. In normally, uncertainty is good or bad?
For bad. For bad, sir.
Uncertainty is not good for a typical physics system, right? But
Yes,
for
sir.
our information theory, uncertainty is good, because more the uncertainty, more the information. Just giving you an example, I transmitted something like, okay, from the previous example, 0 is 001. That is actually my coding, for example. You know it now. certainly you know the 0, 0, 1 will be encoded as 0. If it's certain, then what is the point of this encoding, isn't it? If I can make it uncertain, then this one is still carries information. If you knows it, this is not an encoded data. I could not encode the data because I could not introduce another uncertainty in the system. So the length, the question is, you see, you are increasing the code length. This example, do you understand this example, guys? That my one is can convert it to anything, right? For example, you have a 1, you can convert it by 3 bit 0, 0, 1, or you choose that, okay, I will use 0, 1, 0, 1, 0, 0, 1, whatever. The length you goes on will increase what? Increase what? Uncertainty, right?
Uncertainty.
Yes, but can
Yes,
you
sir.
go unlimited? No, because you have a limited what? Bandwidth. You cannot go on. Means somehow you have to, someone has to restrict you. Means your L length of this one has to be restricted by what? By this entropy. This guy. Yes or no?
Yes, sir.
Okay. Now in entropy, I have written an equation in your system, Hx. So what is an Hx? Hx, which is actually the entropy. Hx is, let me check the formula. I forget what was the formula. Mm, mm, okay, so Hx is nothing but I equal to 0 to m minus 1 pi log 2 pi. What is this pi here? Pi is nothing but the PDF, probability density function of ith symbol. For example, we have S0, S1, S2, blah 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 blah, blah up to S m minus 1. There is somewhere is I, this ith probability. Okay, so sum of all the probability with log 2, because either is 0 or 1. So that will give you the ith value. Okay, just remember it, we will use it in later one. Okay, now today's review class is mostly Huffman code. Huffman coding. What did this coding do? This coding actually generates a series of prefix free code. We need so far we understand that we need, when we encoded a system like 1 or 0, I will encode to something. What should be my coding equivalent code? So Huffman code will actually generate that prefix free code. This is an algorithm actually. This algorithm can generate a efficient prefix free code. Okay. Now let's start. Let's say this is my source signal X, which belongs to a signal. Of course, this signal is nothing but a combination of symbols: S0, S1, S2, S3, S3, and S4 for our cases. Okay, means actually we have 1, 2, 3, 4, 5, five symbols code. Now the probability of S0 is 0.15. The probability of S1 is 0.2. The probability of S2 is 0.15. The probability of S3 is 0.25, and the probability of S4 is 0.25. 25 is nothing but 25%. Okay. Now, if you add up, the sum will be 1. There, all the probability is actually 100%. Okay. Now we say how we want to, now question, how Huffman coding will help us to generate this S0, S1, S2, S3, and S4. This is the question. so that S0, S1, S2, S3, S4. How Huffman coding or algorithm will help us to generate S0, S1, S2, S3, and S4 so that their equivalent probability will be this. Their corresponding probability will be this. The corresponding probability will be this. Understand? Okay. So what are the steps? So I will write the steps. Okay. So okay, next. So let's write the find the steps. What we should do? Step 1. So step 1 says list the symbols in decreasing order. So list symbol symbol means S0, S1, S2, S3, their symbol. Symbols in decreasing order. Okay. So if I do that one, you see decreasing order. So decreasing order of probability. So who are the lowest here? Decreasing order, so highest, from the highest to the lowest. So 0.25 then. Okay, so let's the highest has a S3, has a probability 0.25, S4 0.25, S1 0.2, and S2 0.15, and S0 0.15. Like decreasing order, we plot them in the decreasing order. Okay, so step 2, what should be step 2? Step 2, once we decrease plot it in the decreasing order. Step 2 is fuse the two symbols. Fuse the two symbols. Okay, with the lowest order, with lowest order probability. Now what it's saying actually is asking us to fuse them together. Okay, so while we'll fuse them together, we'll actually give it a name. Okay, so this is branch 0, this is branch 1. That's it's saying, and add them. So what will be 0.5 and 0.5 is 0.3. So this will be goes on. So you see, once we have 0.3, what will be step 3? Step 3. So we add them, add there. So assign. Oh, second one is assigning. Assign 0 and 1 branch, which is we did here. Okay, so step 4. In step 4, what we have to do? Step 4 is the reorder. So what we are doing? Reorder of the probability, actually. Reorder the probability. You see, the probability increases here. Means if increases, then what will happen? It have to go to the top. Okay, so it will go to the top, because this probability changes 0.3. Then they comes 0.25, 0.25, and 0.2. Okay, we'll do this again. We will fuse together. The upper branch is 0, the lower branch is 1. Fuse together. So 2.5, 0.25, and 2. How much? 4.5, isn't it? 0.45, which increases. So it will go to the top again. 0.45. So 0.45, then it will go 0.3, 0.25, right? Again fuse together. The upper one is 0, lower branch is 1. If I fuse together, what will happen? 0.3 and 0.25, 0.55, 0.55. So this 0.55 goes again to the top, 0.55, and this goes 0.45. If you again fuse together, what will happen? Upper branch is 0, lower branch is 1. If this time you add them, what will happen? This is actually 1, summation of 1. Which one? This one. All the probability is 1. This probability, if you add sum of 1. Sum of 1. So you will do this step until you goes to the maximum value of summation of this 1. Guys, understand so far?
Yes, sir.
Okay. Now, what should be the step 4? Step 4 is nothing, 5 is nothing but the repeat. Repeat 2 to again 4. Repeat 2 to 4 step. So now we want to say this is a tree. There is a, we want to create a tree, kind of tree. So we wanted to create a tree. In this tree, for example, S0, we want to see who will be the, what is the code for S0? What is the code for S0? Okay. So S0, what we find? You see, I'm going from S0. What do you find? You look here. You find 1. You find 1. Then this. So this 3. This 3 goes here. What do you find? 0. So 0. So then you are going here. What do you find? 0. And you reach to 1. You reach to 1. So you find 0. So you see, this 0, 0, and 1 is the code for S0. Code for S0. Got it, guys?
Yes, sir.
Okay. Sorry?
Yes, sir.
Okay. So for S0, we find code 0, 0, 1. Let's say we are looking for code for S2. Code for S2. I will again go. From S2, what you find? 0. First, you find 0. Then going in this direction. Then going in this direction. You will go until you find 1. Your job is to come here. Just then you find 0. Then you find 0. So you find 0. Then from the 0 you go 0. Then you find so you find this 0. You find this 0. You see, you are you can find the code for S0 as an S2. So similar to this one, you actually can find all the codes. Okay. Now I will make a table for them. Okay. Let's say what they have. S0. Now summary. S0, S1, S2, S3, S4. So what the code you got? Okay, for S0, what is the code?
001.
0, 0, 1. For S1, the code will be 1, 1. For S2, the code will be 0, 0, 0. That we already find. For S3, 0, 1 and 1, 0. Okay. Now, we want to see what is the length.
Yes.
Okay. So, what is the length? Length. This is a 3-word code. So 3 length. This 2-word code is 2. This is 3-word length. This is 2. This is 2. Isn't it? What was their probability? Remember, it is given there previously. So we'll, okay, this is the probability. We already given here. Here we can also see this binary as a binary tree. So upper branch is always 1 and lower branch is 0. Upper branch is 1, lower branch is 0. So you see, we have ST is 0, 0, 0. So 0, again 0, again 0. So 0, 0, 0 is what? S2. Here will be our S2, isn't it? And
Yes, sir.
1, 1, 1, 1. Anything is 1, 1? Yeah, S1 is 1, 1.
S1.
So S1 is 1, 1. Okay. Now 1 1 and what is 1 0? S4 is 1 0. 1 0 is S4. S4. Okay, what else? S4 is there. S0. Is okay. S0 is 0 0 1. So 0 0 1 is 1. S0. S1 is we done. S2 0 0 0 we done. S3 0 1. So 0 1. You see 0 1 is S3. You see here none of them are predecessor to any other one. S1 is not, S4 is not, S3 is not, S0 is not, S2, and they are have a similarity. They are in the leaf of this tree. Means they are prefix free code. Prefix free code. You see by Huffman how we created this code. This we generated this code, but they are and they are prefix free. We can prove it by our binary tree, isn't it? We can. Okay, now we have this table. We want to see what is the L value, this L length. Okay, so we know from our first lecture this L is the average length. Remember what is the L is the average length.
Yes, sir.
Average length is nothing but I equal to 0 to
Multiplication.
m minus 1 pi li. Pi is the probability of I, li is the length of I, which is actually in our case sum of all the probability with multiplication of the length. Means we will multiply this with this and sum, multiply with this and sum. Understand? So this is
Yes,
actually
sir.
multiplication probability with the length, multiplication of the probability with the length, and summation of from 0 to all the values, means all. Okay, so if you do this operation, means actually 3 into 1.0.15 plus 2 into 0.2, so 2 into 0.2 plus 3 into 0.15 plus 2 into 0.25 plus 2 into 0.25. Okay, so our result will be
2.3, sir. 2.3.
bit per second, bit per symbol. Now this is actually our for our average length will be 2.3 bit per symbol. Means per symbol what is our any 1 or 0 will be can have maximum 2.3 bit. Okay, okay,
Yes,
now
sir.
okay, now we will apply this formula. Okay, is our we find the average length, but how to connect it with the entropy? This entropy will be connected by this formula, isn't it? This formula. So we will write this formula for this one. H. What is the hx value in this system? Okay. So for hx, we'll actually try to have this formula. Means actually we'll do what for hx? We'll actually find all the pi. Pi is the probability of I and log 2 of that probability. Okay. Okay. So from 0 to, so we'll actually uh, do all the probability. So we say we say
Sir,
here
will it be the inverse of the probability or normal probability? Log 2 of inverse or normal, sir?
log pi. This is actually pi. Yeah, it should be inverse 1 by pi. 1 by pi. Yeah,
Yes.
yeah. Thank you. So we will try to find all this one. Here we can see 0.15 comes 2 times. Then 2 comes 15 and 2.25 it comes 2 times. So we can write it very simply. So 0.5, which is actually the 15, which is actually our what is called the probability, but we have 2 times this guy. So 2 times into log of 2, 1 by 0.15 plus 0.2, it comes as a single times into log 2 of 0.2 plus our 0.25 it comes 2 times. That's why multiplied by 2. So log 2, 1 by 0.25. So if you solve this equation, you will find the value is 2.2855. There is a similarities here. You see, our minimum length was what? 2.3. This was our minimum length, which will be bounded by this equation. This equation. Okay. Now we want to see what is their difference. Means if I subtract L minus HX, what will happen? L is 2.3 minus 2.2855. Means actually you see the difference is very low. Why? Because one is giving me the theoretical limit. Okay, 0.0145 what? Bits per symbol. Now you see our this L is gives us the average length, right? Which is actually our average length of this code. Leng average length. What this HS gives me the entropy, means actually theoretical value. Means it's saying that your code word should be this length, but of course you we cannot generate code word in between. So your code word is up to this two. So this is a practical value actually. So this is actually kind of error. Means actually we said our entropy is saying that you see L should have a value at least equal to me entropy or higher. You can have a value equal or higher than me entropy, which is actually a theoretical value for this code. So what this theoretical value of entropy is trying to give you, you see what was I give you the definition: average uncertainty associated with the source. Entropy is saying that okay, to make things as uncertain, your length should be this value. Of course, you find a practical value, so this is the kind of error in your system. So which is very low. Means actually you almost by generating Huffman code, you actually generate almost a theoretical bit length, which is actually gives us this one, gives us the decision whether your where is that one example, whether this should be your length, whether this should be your length. Okay, you want to have a higher length to secure your system, but I have a constraint of bandwidth, I cannot allow you. So let's come to a common term like in between, like optimum. So this is how you figure it out. Got it, guys?
Yes, sir.
Okay. So guys, source code will be end here. We will no more have a lecture on source code. Our next and only one topic remain is the channel code. Little bit bigger chapter, so that's why I cut down all other things so that we can have a little bit longer lecture on channel coding. Okay, guys. Question.